This is the question we are solving today. So we have let T of R3 mapped to R3 be defined by this function. So we should find the following: R of T, kernel of T, the rank of T, and the nullity of T. So to find all of this, where we are going is not far. But what we needed to know before we can solve this is what is merge. So let me quickly explain what we need to know before we can find the solution to this. And that is knowing what we call the echelon form of matrix. So I've taken us to page 6. So here, I prepare a note on echelon form of matrix. What do we call echelon form? Echelon form is also known as row echelon form. And that is a simpler version of a matrix that result from using elementary row operations. Now, what do we call row? You know what a matrix is? This is a matrix. Let me change that to red for it to be visible. Okay. So we know this is what we call a matrix, a rectangular representation of values in rows and column. This is what we call row, horizontal, and the vertical is what we call the column. So this is a row, and this is column. So a simpler version of a matrix that result from using elementary row operations like additions, multiplication is what we call the echelon form. Now, why do we use echelon form? It allows you to solve linear equations easily, to find rank, to find the kernel, to determine linear independence, to simplify matrices without changing the solution set. So if you remember what the question is, the question we are supposed to solve, you will see that we need this echelon form. Looking at the uses here. Now, mathematics is just like a game. It's a game, yes, because it has to do with algorithm, step-by-step solution. And for every algorithm, for every game you play, there are rules. So let's look at the rules that guide echelon form. This rule is what will help you to know how to write a matrix, a given matrix in its echelon form. So the rules are not much. We only have 3 of them. The first one is all non-zero rows are above any rows of all zeros. When we say non-zero rows, that is a row that contains a value other than 0. If you look at this matrix, the example I put under it, the last row, this row, is one that contains 0 throughout. So it's a 0 row. The second row, this one, is not a 0 row because we can see 1, you can see 4. The first row as well is not a 0 row because we can see 1, 2, minus 3. So this rule is saying that all non-zero rows are above any of all zeros. So that's the first rule, and I've given an example of what that is. So here now you see that the 0 row is at the bottom, while the other rows that are non-zero, they are above. Now the second rule is each leading entry, also known as pivot, is to the right of the leading entry in the row above it. What do we call a pivot? A pivot is the first non-zero number in a row. So what this rule is saying is that the leading entries appear like a staircase moving to the right. Picture this echelon form as a staircase, whereby the foundation, what is holding it, they are zeros. So if you look at the example I put here for root 2, you see that taking it from the first column, that's 1, 0, 0. You see that the pivot there is 1, because that one is the first non-zero number in that particular column. So 1 is the first non-zero. In that row. If you check the second row, this one, for the first row, this one is the first non-zero. For the second row as well, the one here is the first non-zero. For the third row, you can tell that this 4 is the first non-zero. So these are the pivots. These are the pivots. And what happens is that whatever you're having under them will be 0, 0, 0, 0, just like a staircase. All right. So the pivots for this example I've given here, for this matrix, for the first row is 1. For the second row, we also have 1. For the third row, we have 4. Okay. Now let's go on to the third. Let's go on to the third rule. The third rule says all entries below each leading entry are 0. Don't forget the meaning of leading entry. Leading entry means pivots. So all entries below each leading entry are 0, just like you see in the second rule. So if you look at this too, the leading entry, also known as the pivot, for the first row here is 1. For the second row here is 3. Next one here is 7. So below 1, we're having zeros. Below 3, we also have 0. And we have 7 here, though, because we don't have any other number under 7. So that's okay. So in summary now, let me give you a visual representation of what echelon form looks like. What the echelon form looks like. So it looks, that is just like a staircase, like I said, staircase pattern. So echelon forms looks like this, like this. So have this picture in your head. As long as you have the picture in your head, whenever you are trying to write a matrix in echelon form, this is the picture that you'll be looking at. That you have in your mind, because that is where you're going to. So I used to see something in mathematics. Once you have the picture of where you're going to, all you need to do is try to find your way and reach there, reach that destination. So you writing a given matrix in echelon form means you are writing it this way. You are writing it this way. So have this picture in your head, then find your way to get here. The right way. All right. So, and just a quick one. Let me identify the pivots, also now the leading entries here. For the first row to be this one, for the second row to be this one, for the third row to be this one, and that is it. All right, now that we have explained what the echelon form of a matrix is, let's go back to solve the question above. Okay. So now back to the question. We are finding the range of t, that's from figure 1. To do that, to do any of this, we need to first write out the matrix. Write out the matrix from this question. Writing T as a matrix. So solution now, solution. So we have to first write T as a matrix. So I'm writing T as a matrix means you are just writing the coefficients of x1 down here as a column, the coefficient of x2 down here as another column, then x3 down here as another column. So if you check the definition we are given, T of x1, x2, x3 equals to x1 minus x2 plus 2x3, comma. So for the first one, the coefficient of x1 here is 1, here is minus 1, and here is plus 2. So that means we are having 1, minus 1, and 2. Yeah, okay. Now for the next term that we are giving, after the comma, we have 2x1, x2. So 2x1 means the coefficient of x1 here is 2. The coefficient of x2 here is plus 1. We don't have x3, so that means the coefficient will be 0. So for the second row, we are writing 2, 1, and 0 because x3 is not there, so that will be 0. So for the third one, now comma, the third one, we have minus 1 as coefficient of x1 here, minus 2 as coefficient of x2, and 2 as coefficient of x3. So we're having minus 1, minus 2, 2, minus 1, minus 2, 2. So, and here is your matrix formed from the definition given. All right. So now that we have formed the matrix from definition given, what we'll do next is to write it in the echelon form. So we write the matrix in the echelon form. So writing matrix T in the echelon form. Okay, so we want to write in echelon form. I believe you have the picture in your head, like I said. Now, let's walk towards that picture. I can still help you put something like that here. We have star, star, star. This should be 0, star, star. This will be 0, 0, star, or sometimes can even be 0. All right, so this is where we are going. This is where we are going. This 3 by 3 matrix, a 3 by 3 matrix, 3 rows, 3 columns. All right, so to do that, remember I told you we are doing simple elementary row operations that include addition, subtraction, multiplication. All right, so what we do is let's apply, there are 3 rows there, so let's apply R2, implying that we'll be doing R2 take away 2R1. Now, what am I writing? What I'm saying is that I want to change my R2. I started with R2 implying R2 take away 2R1. It means that I want to change my R2, my second row. R2 is the second row. This is R1. This is R2. And this is R3. So what I'm doing is that I want to change my R2. But how do I want to change it? I want to change it by multiplying R1 by 2. Then I will take it away from whatever R2 is. So whatever I'm having is my new R2. That is the meaning. So let's do that together. So since I know that it is only my R2 I am changing, so that means I can just write my R1, write what you see, R1 minus 1, 2. This is R1. Then I'll write what we have in R3. That's minus 1, minus 2, and 2. So these are the things we have in R1, R3. It's only R2 I'm changing. So that's why it is empty now, for now. So to know what will be my R2 now, I will perform this operation I wrote here, R2 minus 2R1. So 2R1, that's 2 multiplied by all of R1. So we'll be having 2 minus 2, 4. 2 minus 2, 4. When you 2 multiply the whole of R1, 2 minus 2 and 4. So I take that away from what we have in R2, that's 2, 1, 0. So if I take away 2 minus 2, 4 from 2, 1, 0, that will be 2 minus 2, that will be 0. 1, 2 minus 2 gives us 0, good. 1 minus 2, that will be 1 minus 2, that's 3. And 0 minus 4, that's minus 4. So this is what I have. All right. Now, don't forget where we are going. You already have the picture by the left of where we are going. Now, you may be thinking that how do I know that I'm supposed to apply R2 minus 2R1? Now, this is all coming from thinking. I mean, thinking. You are the one that you think about it because I told you you already have the picture. So you are the one that will find all the necessary ways by which you can get it. So this comes from thinking that, okay, what can I do? Now I'm not yet there. So I think again, what can I do now? Okay, what if I apply R3 now? This means that I want to change my R3. And how do I want to do that? By adding R3 and R1. I want to change my R3 by adding the existing R3 with the R1. So what this means is that is my R3 I'm changing. I'm not changing the R1 and R2. Please, is always the recent answer you'll be following. Like the new matrix I'm looking at now will not be the old one, the first one, but the one I just called now from my recent application. So I'll be writing, so I'm looking at that of 1 minus 1 2, 0 3 minus 4 minus 1 minus 2 2. So I'm not changing my R1, R2. It's only R3 I want to change. So I'll write the R1 and R2. 1 minus 1 2, 0 3 minus 4. So it's the R3 I want to change. And how do I want to change it? I want to change it by adding R3 and R1. This is the R3. This is the R1. So I will add them both. So if I add R1 is 1 minus 1, 2, and R3 is minus 1 minus 2, 2. So if I add 1 and minus 1, that gives us 0. If I add minus 1 and minus 2, that gives me minus 3. If I add 2 and 2, that gives me 4. So I'm having 0, minus 3, and 4. 0, minus 3, and 4. Okay, I'm not yet there, though it's now looking at like it's, I already have 0, 0, like 0 zeros on that one, so I'm almost there. So looking at what I have here now, I just need to do one more step, and that's if I can just, I know you're already thinking about that too, but because of our time, okay, so let me say it out now. I'll apply, to finish it up, I'll apply R3. That is, I am not changing my, sorry, I want to change my R3 by adding R3 to R2. So I want to change my R3 again by adding R3 to R2. You would have thought the same because you know that, oh, the only thing that is not making this thing perfect is that last row that is not 0, 0. We don't have two zeros there. So I know you would have thought the same as well. So now so which means I'm not changing my R1 and my R2. So I will write them 1 minus 2, 1 minus 1, 2. Okay, let me clean that. So we have 1 minus 1 and 2. So we have 0, 3 minus 4. So it's my R3 I'm changing. So now I want to change R3 by adding R3 and R2. Permit me to erase this part. Okay. So I want to change my R3 by adding R3 and R2. This is R3 and this is R2. So R2 is 0, 3 minus 4. R3 is 0 minus 3, 4. So when I add them, 0 plus 0, that gives me 0. 3 plus minus 3, that gives me 0. Minus 4 plus 4, that's 0. So everything gives me 0, 0, 0. So that means I'm good now. 0, 0, 0. So if you look at this where you see that we have achieved what we are aiming for, that is writing it in the echelon form. So we now have it looking like the picture of what echelon looks like. Okay. So now that we have written in the echelon form, so now let's go back to answering our question. Remember what the first question says, that we should find, let me scroll up to remind you, we should find R of t, that's the range of t. So the range of t here now, the range of t is a set that contains the entries that are containing, that have the pivots, that's the leading entry. So using our echelon form this, we'll see that the leading entry here we have 1 and we have 3. For the last row, they are all zeros. So we don't have any leading entry there. The last row, they are all zeros. First row 1, second row 3, the third row, they are all zeros. So we don't have any leading entry there. So we have 2, 1 and 3. So we go back to the original matrix and compare it. I mean, go back to the original matrix. So we see that our leading rows are from the first column and the second column. So that means from the original matrix here, matrix T, we will consider the first column and the second column. So our answer for range now is the first column and the second column. That's 1, 2, minus 1. Then the second column, minus 1, 1, minus 2. Okay, if you don't get that, you can play the video again. I mean, you can go back and listen to that again to get it right. All right, so this is the range of t. This is the range of t. Okay, and all right, if you don't want to write it this way in form of sets, I mean this way, or you can write it like this. You can write it like this. Say x1 plus 2x2 minus x3, comma, the other one minus x1 plus x2 minus 2x3. So you can write it this way as well. So that's it. Now the second one, that's the kernel of t. Now to find the kernel of t, find the kernel of t from our figure 2. We are going to use this, using ax equals 0. Ax equals 0. But I will change the a now because the a is actually the matrix. I'm changing the a to t because the name of the matrix is t. So that's Tx equals 0. So it's actually our x that we want to get that will give us our kernel. The T is the matrix, the x is what we are looking for that will find us, that will get us the kernel. So remember now the matrix T, I won't be writing the original one. I will write the echelon form of it, the echelon form of the matrix that we got, which is 1 minus 1 2 0 3 minus 4 0 0 0. Now our x, we have x1, we have x2, and we have x3, and we have x3. So all of these equals 0 0 0. So remember I told you that echelon form can help you solve linear equations easily. You're about to see it here now. So solving this is very easy. All I just need to do is, if you check the third row, they're all zero, so I don't need to use that. For the second row, I can use it. We have 0, 3 minus 4. So and that's 3x2 minus 4x3. I didn't consider the 0 in front because 0 is nothing. It becomes 0. So equals to 0. So I will make x2 the subject here. So x2 becomes 4x3 divided by 3. So this value of x2. Now, I'll also consider the first row, 1 minus 1, 2. That's 1x1 minus 1x2 and plus 2x3 equals to 0. So remember that x2 is, remember that we have this, that x2 is 4 over 3x cubed. So which means that wherever I see x2 here, I can replace it with 4 over 3x cubed. So 1x1 is same thing as x1. So this is minus 1x is also same as x2, which I can now write my 4 over 3x cubed plus 2x cubed equals 0. So solving this now, I want to make x1 the subject. So you agree that I multiply through by 3. That would be 3x1 minus 4x cubed. No, that should be, 4 plus 6x cubed equals 0. And this is 3x1 plus 2x cubed equals 0. So making x1 a subject, now you have x1 equals minus 2x cubed divided by 3. So now we have our x1 as well, though they are in terms of x cubed, and that's how you do it. That is how you do it. All right, so our x1, x2, we now have it, though, in terms of x cubed. So what we're having is x1, x2, x cubed equals, our x1 is minus 2 over 3x cubed, comma, our x2 is 4 over 3x cubed, and s cubed is s cubed. That's it. S cubed is s cubed. So here now I can factor out s cubed. So if I factor out s cubed, I'm left with minus 2 over 3, 4 over 3, then 1, then x cubed. So therefore the kernel of t, I told you, is those values that we get, that minus 2 over 3, 4 over 3, and 1. But because of the s cubed, so I need to put what we call span. What does spanning means? That is, this particular set I'm writing can generate every other set. So it's actually because of the fact that we are factoring out the s cube. that okay, this is like a basis for every other set. So that's why I'm going to put that was span. Span minus 2 over 3, 4 over 3, then comma 1. So in fact, to even put it in a simpler form, you can decide to multiply through by 3 because 3 is a common denominator. You can decide to multiply through by 3 for nicer integers to have, simple integers. So multiply through by 3. So your kernel will look like this. Span of, your kernel will look at span of -2, 4, and 3. So if you don't want to write it this way, another way you can write it is say kernel of t equals span of, put it in set form this way, -2, 4, 3. Can put it this way. Still okay. All right. So we are done with the range and the kernel. Now the third one is finding the rank of t. The rank of t is just the dimension of dim is dimension. Is the dimension of your R of t. That's range of t. Dimension means how many elements can you find? That's not dimension. So if you go back to your R of t, how many elements can you find? You can just find 2. You can find 2 there. So that means the rank of t is equals to 2. It's as simple as that. Roman figure 4, the nullity of t. Nullity means dimension of the kernel. So dimension of the kernel of t. And don't forget what I told you about dimension. Dimension is the number of something, number of elements. So how many elements can you find for kernel? That's just 1. That's just 1. So 1. So the nullity of t is 1. All right. So we have come to the end of the question. If you find the content educative and you wish to see more of this, please do like, share, and don't forget to subscribe so as always to get notification for other videos. Thank you very much.